Good morning, everyone. I'm delighted to welcome you all today. Today, we'll be exploring an important topic in our field. Dr. S.K. Singh's insights on dirty equipment holding time. This is a crucial aspect of maintaining safety and quality in our work. In this presentation, I will walk you through the key concepts, best practices, and guidelines related to this subject. So, let's get started and dive into the world of equipment management and sterilization. Let's talk about the dirty equipment hold time, or DEHT. This is the period starting right after a production run ends and lasting until the cleaning process begins. Essentially, it's the time during which equipment is considered soiled or not yet cleaned. Some people also refer to this as the soiled equipment hold time. It's important to remember that this is different from the clean equipment hold time, which applies after cleaning has been completed. So, in our overall process, DEHT helps us understand how long equipment stays in a soiled state before it gets cleaned, which can impact quality and efficiency. Keeping track of this time helps ensure that we maintain proper hygiene and prevent contamination in our production lines. Let's talk about why dirty hold time really matters. When equipment stays dirty for too long, residues can start to harden, which makes cleaning much less effective. This means it takes more time and effort to properly clean, increasing the risk of contamination. Additionally, if equipment remains soiled for extended periods, microbial buildup can occur, creating a potential safety concern. From a regulatory perspective, guidance expects that hold times are scientifically justified and carefully controlled. This is crucial to prevent cross-contamination and to ensure that cleaning processes are truly effective. So, understanding and managing dirty hold time is key to maintaining both product safety and compliance. Let's take a closer look at some key regulatory and GMP requirements related to hold times and cleaning validation. Starting with the FDA, specifically 21 CFR Part 211, it emphasizes that cleaning procedures must be validated. This means we need to demonstrate that our cleaning processes are effective and reliable. Equipment must also be maintained properly to prevent contamination, which includes controlling hold times, how long equipment can be left dirty or clean before it needs recleaning. Moving on to the EU GMP guidelines, particularly Annex 15, it states that hold times for both dirty and clean equipment should be validated within the cleaning validation lifecycle. Essentially, we need to establish and verify these time limits during our validation process to ensure ongoing compliance and product safety. In the ICH Q7 guidelines, the focus is on establishing the maximum dirty hold time. This should be backed by evidence showing that equipment can still be cleaned effectively after that period. So, it's not just about setting a time limit, but ensuring there's a scientific basis for it. Finally, the WHO GMP and PIC-S guidelines require hold times to be justified scientifically and documented properly as part of the cleaning validation. This ensures transparency and consistency in our processes, aligning with the overall goal of maintaining product quality and patient safety. By understanding and applying these requirements, we ensure our cleaning validation processes are robust, scientifically justified, and compliant across different regulatory frameworks. When we talk about risk-based evaluation, it's really about understanding the key factors that can influence how effectively we clean and sanitize. First, we look at product characteristics, things like whether the product is sticky, proteinaceous, or hygroscopic. These traits can make residues harder to remove and can impact our cleaning process. Next, environmental conditions play a crucial role. Temperature and humidity levels can affect how residues dry or adhere, so we need to consider these factors carefully. Finally, equipment design and surface properties are equally important. For example, stainless steel surfaces are common, but joints and dead legs can trap residues and are more difficult to clean thoroughly. So, when assessing risk, we need to evaluate all these elements collectively. Now, moving on to worst-case scenarios. These are the situations where we assume the most challenging conditions. When designing our hold time studies, we focus on the worst-case product or equipment. Basically, the goal is to identify the hardest-to-clean scenarios, because if we can ensure cleanliness in those cases, we can confidently say our cleaning process is effective across the board. So, in summary, understanding these key points helps us develop more robust cleaning strategies. It ensures that even under the most demanding conditions, we maintain the highest standards of hygiene and safety. Today, I want to focus on understanding how long soiled equipment can be held before we begin cleaning, without risking the effectiveness of the cleaning process or compromising product safety. Our study approach involves keeping the equipment idle after use for specific time intervals, such as 0 hours, 24 hours, 48 hours, and 72 hours. At each of these intervals, we sample the equipment's surfaces to check for residues and microbial contamination. The main goal here is to determine if holding the equipment for these different periods has any impact on cleanliness and safety, helping us optimize our cleaning schedules. This way, we can ensure that even if there's a delay before cleaning, it doesn't negatively affect the quality of our products or the safety of our processes. Overall, this study is about balancing operational efficiency with maintaining the highest standards of cleanliness and safety. Now, let's talk about swab and rinse sampling. It's essential to use validated techniques for both swabbing and rinsing when testing for product residues and microbes during the hold period. This ensures that our sampling methods are reliable and consistent, giving us an accurate picture of the cleanliness and microbial status of the equipment or surfaces. Moving on to analytical methods, we typically perform microbial enumeration, such as TAMC or TYMC, to quantify the microbial load. Additionally, we conduct residue analysis through chemical assays to detect any remaining product residues. These methods are crucial for verifying that cleaning procedures are effective and that the environment meets safety standards. Finally, regarding acceptance criteria, these should always be clearly defined in the protocol. They need to be scientifically justified, considering both the cleaning efficacy and the potential product risk. Establishing these criteria helps us determine whether the cleaning process is successful and if the equipment is safe for the next production run. All of these aspects, sampling, analysis, and acceptance criteria, are interconnected and vital for maintaining quality and safety throughout the manufacturing process. Let's take a look at industry practice when it comes to dirty hold times. Many facilities typically start with a window of 24 to 72 hours. This range is often based on a thorough risk assessment and the outcomes of relevant studies. It's important to remember that these are general guidelines, and the exact time can vary depending on specific circumstances. Some organizations might validate longer hold times if they have sufficient data to support such decisions. However, in these cases, providing a solid justification is absolutely mandatory. This helps ensure that any extended hold time still maintains product safety and quality. Finally, I want to emphasize that the approved hold time isn't a one-size-fits-all. It really depends on the product type, the results of risk analysis, and validation data. So, always tailor your approach accordingly to ensure compliance and safety. Now, let's talk about the importance of thorough documentation. It's essential that we hold detailed records of our hold time study protocols, including all raw data, results, acceptance criteria, and conclusions. This ensures transparency and traceability throughout the process. Next, we need to focus on updating our Standard Operating Procedures, or SOPs, to clearly include the limits and conditions for dirty hold times. This helps everyone understand the boundaries and expectations for holding times during manufacturing. It's also crucial to train our manufacturing and QA personnel on these hold time controls and the documentation requirements. Proper training ensures that everyone is aligned and consistently applies the procedures, minimizing errors and maintaining product quality. Finally, integrating our documentation practices with SOPs reinforces a cohesive approach. When SOPs are up to date and well understood, it supports compliance and makes audits or reviews much smoother. Overall, these steps are vital to maintain control and ensure product integrity throughout the process. Now, let's talk about the importance of dirty equipment hold time as a critical GMP parameter. It's essential that this is not just a guess, but something that is validated, justified, and carefully controlled. Establishing scientifically backed limits is key. These should be based on data, not arbitrary numbers. By doing so, we ensure the limits are meaningful and effective. It's also important to integrate these hold time limits into your cleaning validation processes, SOPs, and daily operations. Doing this helps create a consistent approach and reduces variability across the board. And don't forget about proper documentation and risk assessment. These are vital for maintaining compliance and, more importantly, for reducing the risk of contamination. When we thoroughly document and assess the risks, we strengthen our control measures and improve overall product safety. In summary, managing dirty equipment hold time carefully, backed by science, integrated into procedures, and well documented, is fundamental to quality and compliance. These practices are the backbone of a robust GMP program and help us deliver safe, high-quality products. For further support, please don't hesitate to reach out. We're here to help you with any questions or additional information you might need. Thank you for your time and attention today. If there's anything more I can assist you with, just let me know.